Part 2, this is for questions 7 to 11. Question 7 is coming from differentiation, this first part here. But since a is expressed in terms of, again, a here, that means this one can be solved using numerical methods. So I expect the next part to come from numerical solutions. The equation of a curve is y is equal to x out of the cos squared of x for x ranging from 0 to 90 degrees, that is in the first quadrant. At the point where x is equal to a, the tangent to the curve has this gradient which is equal to 12. Show that a is this. Okay, now we need to differentiate this. Our y is equal to x, then out of the cos squared of x. So we can use the quotient rule. This is u, this is v. Okay, so dy dx, remember using the quotient rule, dy dx is going to be equal to v du dx minus u dv dx. Then we divide by what? V squared, if y is equal to the product of these two. I mean, it's the quotient, so u out of v. Now, what is our v? Is this cos squared x. Then we differentiate this x, which is our u, then minus u, which is x. Then we differentiate the v, which is the cos squared of x. Okay, but cos squared of x, I'm going to write it like this: cos of x, then I put the square there. Is that clear? Then we divide by this cos squared of x, then we square. Now, when you differentiate x with x, I mean with respect to x, of course you get 1. So we shall get cos squared of x, then times the 1 here, and then here you drop this power, you get 2, then you reduce the power by 1, so cos x, then times, you enter inside here, you differentiate this, you get a negative sine of x. So this is by using chain rule. Then we divide the whole of this by cos, then power 4 of x. Is that clear? Then the next thing to do is to simplify this. I can actually put cosine of x out here, it is common. Then here we are having cosine of x, a negative and a negative, that one gives us a positive, so we have 2x, then sine of x. Okay, remember I took the cosine outside like that. Then we are dividing by the cosine power 4 of x. Now this one is going to reduce this, not so, and then we get cosine of x plus 2x sine of x, then out of the cosine cubed of x. Now for x which is equal to a, for x which is equal to m, because that is what they said here, at the point where x is equal to a, then the tangent is equal to 12. So the tangent, I mean the gradient, not the tangent, the gradient of the tangent is equal to 12. So wherever there is x, I'm going to put a. So we shall have cosine of a, then plus 2a sine of a, then out of the cosine cubed of a, then I equate this one to 12. Then we can cross multiply here. When we cross multiply, we shall have the cosine of a plus 2a, then sine of a, this one will be equal to 12, then the cos cubed of a. Now there is an a here, there is an a here, there is an a here, there is an a here. So one of them is made the subject of the formula. And then when we look at what we are having here, I'm seeing the cube root. So that means of course the cube root has to come from here. When you take this on this side and then you take that cube root. So it is this a that is made the subject. Now first bring the 12 this side. That means we shall have cosine of a plus the 2a This is 2a. Then sine of a, we divide by the 12. And then that one will give us the cos cubed of a. Then we take the cube root. So this will be the cube root of cosine of a, then plus 2a sine of a out of the 12. By the way, do we have this one as it is here? Yes. Cos of a, 2a sine a out of 12. Good. Then we proceed. Now this one will be equal to the cosine of a. Then how do we get a from there? Then we take the arc cos of everything that we are seeing here. So just duplicate this and put it there like that, and I'm done. Next, part B, verify by calculation that a lies between 0.9 and 0.1. I have always. Then part B, verify by calculation that a lies between 0.9 and 1. I have always used this kind of illustration that if maybe this is the graph that comes from that, and this is our x-axis, where this graph meets the x-axis, that is what we call the root here, okay? Then there is an x-coordinate on the left of the root and also an x-coordinate on the right of the root. Now, when you look at this x-coordinate, it will give us a corresponding y-coordinate, which is going to be above the above the x-axis, based on what I've drawn, okay? I'm just using this as an illustration. But then when you look at this other x-coordinate, it will give us a y-coordinate that corresponds to it, and this one is going to be below the x-axis, which is negative. So what does this mean? If you have a root that is existing between two values, when you get to those values and you substitute them in the function, they are going to give you these opposite signs, okay? One will give you a positive, and then the other one will give you a negative. Now, what we are going to do, when you come back here, you bring this one, this side. You can take this one, this side, or you can take the other side to form a function. You see that? So we are going to have our a here. Let me first write it. A is equal to the arc cos, and we know it is the cube root of, we had cos of a here, then plus 2a sine of a, then out of the 12. We had something like that. So bring this one this side, and then you have a minus the arc cos of the cube root of cosine of a plus 2a sine of a, then out of the 12. So that is what we are having there. Then this one is equal to 0. Remember, to get the root of a function, the function has to be equal to 0, so that when you substitute that value, you get the 0. And the root is called the 0 of a function. Is that clear? All right, so that means our function in terms of a is going to be everything that we have gotten here. So this is the one that we are going to use. Now, what do we get when we substitute the 0.9 wherever there is a, and also when we substitute a 1? So we shall get the 0.9 minus, I'm just going to put, okay, let me write it, arc cos of the cube root of cosine of 0.9, then plus 2 times the 0.9, then sine of 0.9, and then we divide this by 12. So what do we get here? Is it positive or negative? We shall find out. Then I'll also just get this, and then I duplicate it. Okay, I'll duplicate it. Let me first take away this. Then wherever there is a 0.9, I'm going to put a 1, not so? So you put a 1 everywhere. There is 0.9. So f of 1 shall be 1 here minus cos of 1, then 1 here, 1 here. Now, since we are having trigonometric functions here, the calculator must be in radians. Calculator in radians. The moment you press degrees, you might fail to get this. So what we get here and then here. My calculator here is in degrees. I need to convert it to radians. So shift, then mod, then radian is 4. Now 0. In fact, let me begin with 1. 1 minus the arc cos of the cube root of, we have cosine of 1 plus 2 times 1, then sine of 1. Okay, then down here we have a 12. So we are getting 0.035806. 0.035806, and the rest of those figures that come forth about here. So I'll come to this, and wherever there is a 1, I'm going to put a 0.1, 0.9. So we also put 0.9 here, and then we also continue the same thing here, 0.9, and also here 0.9. So we get a negative. That is negative 0.08459. 0.8459. It's a negative. Then we can conclude and say, since there is a sign change, between f of 0.9 and f of 1, then you write this statement here. A lies between 0.9 and 1. And that is that. Then next part, C, use an iterative formula based on the equation in part A to determine A, correct to 2 decimal places, give the result of each iteration to 4 decimal places. Since we are not given the initial approximation, then I can use the average of these two, because if 0.9 is here and then 1 is here and then the root is in between the two, it is better to get the average of the two and then you start from there, not so? So we are going to have, let the initial approximation be, let's say A1 is going to be equal to 0.9, then plus 1 divided by 2. This one has to be 0.95. Then what will be our A2? You show the substitution of this one here. So this one is going to be the arc cos of the cube root of cosine of 0.95, then plus 2 times 0.95, then sine of 0.95, then you divide by the 12. Now what do you get here? Remember, your calculator has to be in radians, not so? I will come back here, take off this. Then we go inside here, wherever there is 0.9, I will put 0.95. 95, and also here 95. Then you get 9743, 0.9743. The rest you don't need to show the substitution, only show this first one here. So here we'll just write A3, then A4, A5, maybe A6, like that. Okay, now let's go back. We put this one wherever there is 0.95, we substitute this. But you don't say, you go back to your calculator and then you put here answer. No. It might fail. So you put this rounded figure here. So I will come back to this and then I put 9743. 9743. We also go here, we do the same, 9743. And also this other side, 9743. So we get 9694. 0.9694. We repeat that. 0.9694. 96694, and then also here 9694. So we get 9704, 0.9704. Now, when do you know that you're supposed to stop? You look at your rounded figures. So this one is 97, this one is 97, and this one is 97. So since these three values are giving me the same rounded figure to two decimal places, I will just stop there. So I don't need to take these other values here. You have to get three values that are giving you the same value correct to the required degree of accuracy. Suppose I got these two. This is 9743, and then also this one is giving me 0.97. But then when I put here, when I put in the next one, it diverges a bit. That means you need to continue, okay? So our A is therefore going to be 0.97. That is to two decimal places. And that is that. Question 8 is coming from word problems in differential equations. In a certain chemical reaction, the amount X grams of a substance is increasing. The differential equation satisfied by X and T, the time in seconds since the reaction began, is this one here, where K is a positive constant. It is given that X is equal to 20 at the start of the reaction. Part A, solve the differential equation obtaining a relation between Xt and K. Now, the first thing we do is, of course, to separate variables, and then we integrate. So separating variables and integrating gives us what? We have to put t on one side and x on one side. So I'll just cross multiply here. When I cross multiply, this x will just go here, then the dt will come up there. So we shall have dx, then out of x, this one will be equal to k, then e to the power of negative 0.1 of t, then dt. If you want, you can take this k together with the x down here, but no need. Then we integrate, okay? When we integrate, you know that when you integrate e to the power of f of x with respect to x, what you're going to do is to get this exponential function, then you divide by the derivative of the power of that exponential. So we divide by that. If it is differentiation, then we are multiplying it here. See that? All right. So of course here, when I differentiate x with respect to with respect to x, I get a 1 that is up there. That means we shall get the natural log of x here. Then we come to this one here. This one will be k, then e to the power of negative 0.1 t. When you differentiate this with respect to t, you get a negative 0.1, which you divide, just like the way I said you do here. Then we shall put an arbitrary constant here. But this arbitrary constant, you can put it on the left or on the right. But since we are not integrating the same functions, we can actually have natural log of x plus a constant here. You also have this one here plus another constant. But this constant minus this constant will give you a certain constant. So you just put that c value on the one side. And I prefer you put it on the right. Okay? So here we are going to have the natural log of x. 1 over 0.1 gives you a 10. So we shall have negative k, then e to the power of negative 0.1 of t. Actually, this is negative 10. Pardon me here. Negative, I need to put a 10 here. Negative 10k. And then, let me just take off everything. So negative 10k, then e to the power of negative 0.1 of t, then plus c. Now we need to find the values of k and c. Now from here, they say that it is given that x is equal to 20 at the start of the reaction. So at the start of reaction, that is when t is equal to 0. Okay, so for t is equal to 0, then we have x is equal to 20. Okay, now you have the natural log of 20, then this one will be equal to negative 10k, then e to the power of course 0, then plus the c. So what are we going to have? This c here, you take this on this side, so our c shall be equal to the natural log of 20, then plus 10k. Not so. Here, of course, this one is 1. So that means our general solution, remember when we solve this one here, before finding this arbitrary constant here, what we get here is the general solution of the differential equation. Then after getting that arbitrary constant, what we get is the particular solution. So therefore, our particular solution is natural log of x, which is equal to negative 10k, then e to the power of negative 0.1 of t, and then plus, this will be natural log of 20, then plus 10 of k. Okay, so they said obtaining a relation between xt and k. I can even leave it there, but I can simplify it further. Okay, and I say this will be natural log of x, which is equal to, now we can see 10k, which is common here. So I will say 10k. Now this one is positive, so that will be a 1. Then there is a minus here, so minus, then e to the power of negative 0.1 of t, then plus the natural log of 20. So I can leave it there. Even if you leave it here like that, no problem. Then part B, given that x is equal to 40 when t is equal to 10, that means they want us to find the value of k. So find the value of k and find a value approached by x as t becomes large. Now, we already know that our natural log of x is equal to, we said 10k into 1 minus e to the power of negative 0.1 of t, then plus the natural log of what? 20. Not so? This one looks ugly. So plus the natural log of 20. Now x is 40, so we shall have natural log of 40, which is equal to 10k, and then 1 minus e to the power of negative 0.1. Our t is 10, then plus the natural log of what? 20. I can bring this on this side, then we get natural log of 40 minus the natural log of 20. Then here we get 10k, and then 1 minus e to the power of negative 1. Okay, and then this one will be the natural log of 40 out of 20. Not so? Then this will be 10k, 1 minus, I can say 1 over e. So what will be k? Here we shall get natural log of 2, then we divide by 10, then 1 minus 1 over e. That will be the value of k. And then I can write it maybe to 3 significant figures. Natural log of 2, then we divide by 10 into 1 minus e to the power of negative 1, like that. So we have 0.109654, 0.109654. Okay, and I can leave it there. So this k maybe to 3 significant figures, or I can just leave it like that. Okay, if you want you can write it to 3 significant figures, but that one's okay. Then find a value approached by x as t becomes large. Now this is natural log of x, which is equal to 10k. Now from here 10k can be the same as, if you bring this one back here, it is going to give you what? Natural log of 2 out of this one, not so? So I can say this one is natural log of 2 out of 1 minus e to the power of negative 1. You see that? That is the k, the 10k. Then times 1 minus e to the power of negative 0.1 of t here. But this one I can write it like this: minus 1 out of e to the power of 0.1 of t, not so? Then plus the natural log of 20. Now, as t becomes big, what does this mean? As t tends to infinity, so we shall get 1 over, so e power infinity, or like e power a very big number, still gives you a very big number, not so? Now, that means this part here, 1 out of e to the power of 0.1 t will approximate to 0, because 1 over a very big number always goes to 0. Like you can have 0.00000. Okay, you know this one here, that 1 out of 0 is undefined. Now, when you cross multiply, is undefined. So when you cross multiply, don't you say 1 over infinity is equal to 0? So that's why this one is disappearing. Then you can have this x here, the natural log of x. Now this one goes, then times this, and then that. Okay, so x now tends to e, because from here to get the value of x will be e to the power of whatever we are having this side. So e to the power of, this is natural log of 2 out of 1 minus e to the power of negative 1. Okay, then plus natural log of 20. So when we press this in the calculator, this x here tends to which value? E to the power of, we are going to have a fraction here. This is natural log of 2. And then down here we are having 1 minus, then e to the power of negative 1. Then after that fraction there, we have natural log of 20. Then all together, what we have? 59.9. So it is 59.9. That is to 3 significant what? Figures. And that is that. Question 9. The diagram shows part of this curve here, where x is greater than or equal to 0 and its minimum point m. So since this one is a minimum point, it's a stationary point. And we know that for stationary points, dy dx is equal to what? To 0. So that is what I'm going to begin with. For stationary points, dy dx is equal to 0. So they are telling us to find the exact coordinates of m. We need to differentiate. We equate to 0. We find the value of x. Then after getting the value of x, we substitute in here to get the value of y. Okay. So since this is a product of two functions, then to get our dy dx, we are going to use the product rule. So we shall keep this 3 minus x constant. Then we differentiate this exponential function here. Okay. Then from there, we keep this exponential function here constant, and then we differentiate the 3 minus x. And you know that when you differentiate an exponential function, okay, you get the power of that exponential, you differentiate it, then after you multiply it with the whole of that exponential function. We shall equate this to 0. Now, when you differentiate here, that means we are going to get, here you are going to get negative a third, not so? So you get that negative a third, then times e to the power of negative, this a third of x, and then plus, you have this e power of negative x over 3, and then when you differentiate this with respect to x, you get a negative 1, which is equal to what? 0. Then from here, what do you see common? I can see e, in fact negative e to the power of negative x over 3. That can say negative, then here, and also this negative, and then that. So I can factorize it, and then here we are getting the 3 minus x over 3. Okay, remember I took out the negative. Then here we shall have plus 1, not so. Because the negative I put it, I already pulled it outside here, then this one is equal to 0. All right, now this is negative e to the power of negative x over 3. And then what do we have here? We can simplify this, and then we have 3 minus x, then plus 3 out of the 3, which is equal to 0. Then we get negative e to the power of negative x over 3, then out of this 3, which is here. And then inside here, we are having 3 plus 3, that is a 6. So 6, then minus x, which is equal to 0. Now we shall get these two factors, and then we equate them to 0. So we also have 6 minus x, which is equal to 0. Now there is no number that I'm going to power this e with, and then I end up with a 0. So therefore this one is undefined. Is that clear? Then we come to this one here. That means x is going to be equal to 6. Now for x, which is equal to 6, what is going to be our y? Y will be equal to, it is 3 minus x. So you have 3 minus the x, which is a 6, then e to the power of negative x, which is a 6, then out of the 3. And then this one will give us negative 3, then e to the power of negative 2. Not so? So this therefore implies that the coordinates of m will be 6, and then negative 3, e to the power of negative 2. And that is that. Then part B, find the area of the shaded region bounded by the curve and the axis giving your answer in terms of E. Now when we check back here, we are moving from, so the limits are going to be 0 and then here. Now at this point here, the curve is cutting x-axis, and on x-axis, what do you know? Y is equal to what? 0. So I'll come here, and then I first find that x coordinate. Then we say on x-axis, y is equal to 0. So you have your y, which is 3 minus x, then e to the power of negative x over 3. You equate this to 0. So you have the 3 minus x, you equate it to 0, then your x is going to be equal to 3. Of course, when you get this one here and you equate it to 0, this one is undefined, just like before. There is no number you're going to power this e with to end up with the 0. So that means our shaded area then shall be equal to the integral from 0 to 3, and we are having 3 minus x, then e to the power of negative x over 3 with respect to x. Now this is a product of two functions, so here we use integration by parts. Okay, in integration by parts, we say that when you are integrating u, then dv dx with respect to x, you get uv minus the integral of v, then du dx with respect to x. So this is what we are going to use here. Now, one function has to be differentiated. You see here we are having a u, but then this side we have du dx. That means that function has to be differentiated. And then this is dv dx, but then here we are having v. That means to get the v from dv dx, you have to integrate. So one function has to be differentiated, the other one has to be integrated. How do you know which function to differentiate, then which one to integrate? You use this acronym ILATE. Now, this one represents inverse trigonometric functions. L is for logarithmic functions. A is for algebraic functions. T is for trigonometric functions, because trigonometric functions are treated differently from inverse trigonometric functions. And then E is for exponential functions. Now, looking at what we are given here, this is algebraic function, and then this one is exponential function. So which one comes before the other? Algebraic. So that means that is the one we are going to differentiate. So the one that comes before the other is the one you differentiate, okay? Then the other one you integrate. So we shall let our u to be equal to that 3 minus x. You differentiate this u with respect to x, you'll get a negative 1. And then your dv dx is going to be this e to the power of negative x over 3. Then to get the v, you would integrate this. And we should also know that when you integrate an exponential function, okay, you do that, you differentiate this, then you divide all through. So you get e f of x, then we divide by the f prime of the x. Okay, and you remember that in the previous numbers that we have done. Now this one here shall give us, when you differentiate this, you'll get negative a third. So you get e to the power of negative x over 3. You divide it by negative a third. This one will simplify to negative 3, then e to the power of negative x over 3. Now, our shaded area is therefore going to be equal to, we are integrating this. So this is our u, this is our dv dx. Now we have u, which is this one. So that is 3 minus x. Then we need v. So v is this one here. So we shall have times negative 3, then e to the power of negative x over 3. You see that? Then minus the integral of v, which is negative 3 e to the power of negative x over 3. Then times du dx. You see this du dx? We are getting a negative 1 here. Then dx. I can actually put these limits here, 3 and 0. Then we first simplify. I'm going to bring this one first. So we shall have negative 3 here, then 3 minus x, and then e to the power of negative x over 3. Then this is a negative times a negative, you get a positive. But again, we have a negative there. So I'm going to put the 3 out. Then I do like this. Now, here you can see that again, we are integrating this one here, which is the same as what we are having here. So I'll just write here that we are going to have negative 3, then 3 minus x, then e to the power of negative x out of 3, then minus, this will be 3, then times, this one will be negative 3, e to the power of negative x out of 3. Not so? And then we have that. Now, maybe furthermore, to simplify this, this will be negative 3, then 3 minus x, and then e to the power of negative x over 3. This one will be a 9, then e to the power of negative x over 3. Not so? Yeah. Now, Mary, if you want, you can pull out this, but it's okay. Let us just substitute. Now put the limits. When I put 3 here, this is negative 3, then we have 3 minus 3, then e power negative 3 over 3, then plus 9, e power negative 3 out of 3. Then we subtract, put 0, so you have negative 3, then there is 3 here minus 0, then e power, this will be 0, then plus 9, e power 0. Now we simplify here. Of course, 3 minus 3, that one disappears. And then here we shall have 9 e power negative 1 minus, this one here is a negative 9. Not so? Of course, e power 0 is a 1. So negative 9, then times negative 1, then that will be a positive 9. And then also this one is a 9, then with the minus here. So minus 9. Of course, that one disappears. That means our answer is going to be 9 e power negative 1, which I can write as 9 out of what? Of e. And that will be my final answer there. Question 10, let f of x be equal to this, but A, express f of x in partial fractions. Whenever they give you partial fractions, first always check the degree of the numerator and then the degree of the denominator. So from here, we shall get x squared coming out, but then times this x, that means you are going to get x cubed. So the degree of the denominator is going to be 3. That is the highest power of x. And then the degree of the denominator of the numerator is a 2. If the degree of the numerator is less than the degree of the denominator, then you can just proceed. But if you find that the degree of the numerator is greater or equal to the degree of the denominator, the first thing to do is to long divide, such that you convert that improper fraction into the mixed one, okay? But now here we shall just proceed. Now here we have 2x squared plus 7x then plus 8. We divide it by 1 plus x. We can see a linear factor here. And also this one is linear but repeated. So that means we shall have a out of 1 plus x. And then we shall have b. Then we take this one when it is not squared. So that is 2 plus x. And then we also now take this one when it is squared. Why do we do like that? When you have, let's say, 1 over 2 plus 1 over 4, this one is the same as 1 over 2, then plus 1 over 2 squared. When I'm taking the LCM, I'm going to take 2 squared because this one goes into that. You see that? We are not going to say the LCM of this is going to be this times this, and then you find yourself multiplying here, then you get 2 power 8. You see that? So here we are taking only 1, but which has these 2 in there. So that's why we do like that. Now, our mandate is to find the values of A, B, and C. So what do we do? Of course, from these 3 here, we are supposed to get the common denominator, which is actually this one here, okay? So you say this one, divide by the x plus 1, the x plus 1 automatically will cancel with this, then you remain with this. So this is what you multiply with the A. So that means we are going to have A into 2 plus x, then squared, then plus. When you get this, divide by this, that means this one will cancel with 1 here. Then you remain with this, then times the b. So we shall get b times 1 plus x, then also 2 plus x. Then next, you get this, divide by this. That means we are going to see this one disappearing with this, then 1 plus x, then times the c, not so? So we have c times 1 plus x. Then after that, we equate this to the numerator, which is 2x squared plus 7x plus 8. I've always shown this. Why do we equate this to the numerator there? It is because this whole thing here is over this one, because this is the common one, denominator. But again, this one is what is also this other side. This is the fraction you're using here. You see that? Now, same denominator, that one disappears. That means this numerator is equal to that numerator. So after multiplying all of these ones here, you equate them to the numerator that is here. Okay? Then the next thing to do is to get the values of x that I can substitute in here such that I can terminate some of the terms. What do you do therefore? You just get these terms here, you equate them to 0. Like if I get this one and I equate it to 0, x will be equal to -1. Then I can say if x is equal to -1, okay? If x is equal to -1, this part here will disappear, even this one will disappear, then I will remain with this one here. So 2 minus 1, what do you get? A 1 squared, that will be a 1. Then times the a, you will get only a, which is equal to, put -1 here, you will get a 2, okay? I mean a 1, then times the 2. Okay, maybe let me substitute 2 times -1 squared, then plus 7 times -1, then plus the 8. That means our a shall be equal to, this one is 2 minus 7, that is negative, or I can just say 2, then plus 8, that is 10, then minus 7, that will be a 3 there. Then also, if x is equal to, you just get this and equate it to 0, x can be equal to -2, not so? That means this one will disappear, this one will disappear, I remain with this, not so? Now -2 plus a 1, you get a -1. That means we shall get -1, then times the c, which is a -c, then is equal to, you get the 2 times the -2 squared here, then plus 7 times -2, then plus the 8. Now -2 squared, that is a 4, then times 2, that is 8, so 8 plus 8, that is 16, then 16 minus 14, you'll get a 2. So you get negative c, which is equal to 2. So meaning c will be equal to negative 2 when you divide all through by the negative 1. Then since the values of x that I can substitute in here to terminate the terms are done, I can use any other value of x. So suppose x is equal to 0. Now this one disappears. So 2 squared is a 4. So we shall get 4a. Then, of course, this one goes, then 2 times the b. So we shall get 2b. And then here we shall get a c. Then this side, these ones go. Then we have 8. We are supposed to make b the subject on the formula. We shall get 8 minus, our c is a negative 2. So when it crosses, it becomes a plus. So plus 2. And then this 4 here. Then times our a, which is a 3. Then we divide by 2. So this is 10 minus 12. Isn't that negative 2? Then divide by 2. That's a negative 1. So this therefore implies that our f of x is going to be a, which is 3. Then we divide by 1 plus x. Then our b is a negative 1, which is out of 2 plus x. And then c is a negative 2, which we are dividing by 2 plus x, then squared. Now, whenever they give you partial fractions in the first part of the question, expect the second part to come from integration or binomial expansions. Part B, hence obtain the expansion of f of x in ascending powers of x up to and including the term in x squared. Now you see, this one is coming from binomial expansions. So our f of x, we're going to use indices, is 3 out of 1 plus x here. So that means I would just write 3, then 1 plus x to the power of negative 1. Then we have this 2 plus x will go up. So I'll have 2, there's a minus here, then 2 plus x to the power of negative 1. Then there is a 2 here, then 2 plus x to the power of negative 2. Not so? Yes. Okay, now using the binomial expansion, we know that a plus b to the power of n, this is a, then power n, b power 0 out of 0 factorial. The power of the b is the one that we put in the factorial in the denominator. Then the next one, you'll be like you're differentiating with respect to a. So plus, you drop the power, then reduce it by 1. Then when a loses the power, b picks that power. Then 1 factorial, then plus, again drop this one here. You'll get n, then n minus 1, then a to the power of n minus 2, then b to the power of 2, out of the 2 factorial. And whenever you are adding these powers, you always come back to this n. So n plus 0, n minus 1 plus 1, then n minus 2 plus 2, you get this n here. Now, I'm going to start with this one here, which is 1 plus x, then to the power of negative 1. So our n is negative 1. Okay, so what I'm going to have here is my a is a 1. So power it with a negative 1. Then my b is the x, power it with a 0. Then out of 0 factorial. Then drop this one down here. We shall get negative 1. And then this one will be 1. Then power negative 2. Then x here, power 1. Then out of 1 factorial, we are ending here, so plus, then drop the negative 2, so you have negative 1 times negative 2, then you have a 1 here, now power negative 3, then x here, then to the power of 2, then out of 2 factorial, then plus the rest of the terms that come forth that we ignore. Then 1 power any number is a 1, but then 0 factorial is a 1 because there is only one way to arrange an empty set. Then, of course, a negative. Here we shall get minus, then the x, and then this is a negative times a negative, which is a positive. That one will cancel with the 2 factorial, and then we shall get our x squared there. The rest we ignore. Then we go to the next one here. We have 2 plus x to the power of negative 1, and then this one can be equal to, we get, if you want, you can create a 1 here, then plus this will be x over 2, and then you expand this one here, but I can just do this. I can just take it all at once. So we have 2, then power negative 1, then we have the x then to the power of 0 out of 0 factorial, then plus now negative 1, then times this 2 power negative 2, then x to the power of 1, then out of 1 factorial, then plus negative 1, then times negative 2, then you have 2, then to the power of negative 3, and then x here is to the power of 2, then out of the 2 factorial. Then here we can have a half, and then what else do we have? So here we 2 power negative 2 is the same as 1 out of 2 squared, which is a quarter, not so? So we shall have, there is a negative here, so negative a quarter of x, and then of course this one is going to go with this, then 2 to the power of negative 3, that is 1 over 8, then x1 squared, ignoring higher powers. Then we go to this other one here, we have 2 plus x, then to the power of negative 2, so we shall have 2 power negative 2, then x here begins with the power of 0, then over 0 factorial, then plus, drop this negative 2, reduce it by 1 here, then x to the power of 1, then out of 1 factorial, then plus the negative 2 here, then multiplies with the negative 3 that comes from up there, and then the 2 here reduces by 1, so this will be negative 4, and then x here to the power of 2, then out of the 2 factorial. Now this one will give us 2 to the power of negative 2, that's a quarter, and then here what do we have? We have negative 2, then times 1 over 8, because this will be negative a quarter. So minus a quarter of x, and then this one, the 2 is going to cancel with that, okay? A negative times a negative, that's a positive, so we shall get 3, then times 2 to the power of negative 4, this is 2 over, that is 3 times 1 over 2 to the power of 4, which is a 16. Yes, so 3 out of 16. So we shall get plus 3 out of 16 of x squared. Then that means that our f of x is equal to, remember up here there is a 3, so we have 3 here, then times the expansion of this one here is 1 minus x, then plus x squared. Then we also have minus the expansion of this one here, so we have a half minus a quarter of x, then plus 1 over 8 of x squared, then plus, is it a plus or a minus? It's a minus, there is a minus 2 here, so minus 2, then times this one here, which is a quarter, then minus a quarter of x, then plus the 3 out of 16 of x squared. You see that? Now I'm going to separate the terms here, so the constant terms are going to be 3 times 1, so we have a 3 here, then negative, and then this a half, so we shall have negative a half, then the negative 2 times this a quarter, that one will be negative a half, not so? Then we go to the terms that have gotten x. The terms that have gotten x are 3 times this one here, so that will be negative 3. The negative of this one, that will be a positive, a quarter. Then negative 2 times negative a quarter, that one will be a plus, then a half. So that is of x. Then we continue. 3, then times this for the x squared, so we shall have a 3, and then negative of this one, we shall have minus 1 out of 8, then negative 2 times this 2 here will go in here 8 times, so it is negative 3 out of 8, not so? Minus 3 out of 8. All of these ones are terms of x squared. Now simplified, this one is a 1, so 3 minus 1, we shall get a 2, and then how about here? So we shall have negative 3 then plus 3/4. So negative 3 plus 3/4. This one will go give us negative 12, then plus 3, that will be negative 9. So we have negative 9 out of 4. Negative 9 out of 4 of x. And then how about here? 8 times this, that will be 24. Then 24 minus 1 minus 3 out of 8. 24 minus 4, that is 20. So 20 over 8 by 4, 5 by 4, 2. So it is 5 out of 2. We shall get 5 out of 2 of x squared plus the rest of the terms that come forth, and this becomes our final answer there. Question 11 is coming from vectors. In the diagram, OABCD is a solid figure in which OA is equal to OB, which is 4 units. So OA, this is 4 units. Then OB is also 4 units. And then OD is 3 units. So I can put a 3 there. The edge OD is vertical. DC is parallel to OB. DC is parallel to OB. That means if this one is 4J, this one will also be in terms of J. Is that clear? Then what else are they saying here? And DC is 1 unit. So we have 1 unit there. Okay. Then the base OAB is horizontal and the angle OAB is 90 degrees. OAB. This one is 90 degrees. Okay. Then unit vectors ij and k are parallel to OA, OB, and OD respectively. The midpoint of AB is M, and the point N on BC is such that CN is equal to 2NB. CN is equal to 2NB. So if this is your NB, then we have 2 NBs here. So there is an NB there and then an NB there. What does this mean? CB has 3 NBs, not so? Okay. Now, let us find here what they are saying. Part A, express vectors MD and ON in terms of ij and k. So when we are moving, we have to be moving through these directions here, the ij's and the k's, okay? So MD here, from M to D. Where is M? M is here, so I can say MA, okay, plus AO, then plus OD. You see that? MA, then plus AO, then plus OD. Now, MA, this one is going to be a half of BA. Okay? This is a half of BA. In vectors, you have to master the direction. If I say M to A, then BA. You see that? Then, of course, this OA is moving in the negative direction of what? Of OA. This AO is moving in the negative direction of what? Of OA. So I will have, this is negative OA, then plus the OD. Now for us to get BA from B to A, that is B O, then plus OA. Now B to O is moving in the negative direction of this. So in other words, you get the last minus the first. So we have a half. We say OA minus OB. Then here we are having minus OA, then plus the OD. So we have a half. Our OA is 4I. So 4I. Then our OB is 4J. So 4J. Then what is OA? Is again 4I. And then OD is 3K. Now, we simplify this. This one will give us 2I, then minus 2J, then minus 4i, then plus 3k. And then our m to d is now going to be 2 minus 4, that's a negative 2. So negative 2i minus 2j, then plus 3k. And that is that. Then we go to the next one, how to find this ON, O to N. Now O to N, this one here, we can say O, B, then plus B, N. You see that? Or you can say O, D plus DC, then plus C, N. So I can say ON is equal to OB, then plus BN. So OB is of course 4J. Then B to N here. This is 1, 2, 3. So there are 3 BNs in BC. Are we there? So BN is going to be a third of BC. Are we there? So master direction, very important here. So how do we get BC? We can say BO plus OD, but I think now the better one to use would be the other one, because now we are coming back, wasting time. So ON is going to be OD, that is OD, then plus DC. Okay, DC, then plus CN. So OD is 3K. Then DC, they say that it is parallel to this one here. So, and this is 1 unit here. So it is going to be J. Okay, so plus J, then plus CN is going to be, this is 1, 2, 3. So this one is going to be 2/3 of CB. Of what? CB. Even this one still we have to move around. So 3K, then plus J, then plus 2 out of 3. How do we find CB? That is OB minus OC. But how do you get to OC? So we just say that is CD. Okay, CD plus DO, then plus this. So CD plus DO, then plus OB. Now, what do we have here? This is 3K, then plus the J, plus 2/3 of CD. We are moving backwards, so it is the negative of this. So it is going to be negative J. Then DO, we are moving in the negative direction of this one, so it will be negative 3K. So negative 3K. And then OB is this one here, which is 4J. 4J. Now, we simplify. This is 3K, then plus the J. And then in here, we are having 4 minus 1, that is a 3. So if you get 2 over 3 times 3J, this one goes, so you have 2J inside there. Okay, so plus 2J, and then this multiplied with this, you get a negative 2K. So that means our ON simplified will be, we write the J first. So this is 3J. 3J. Then 3 minus 2, that is a 1. So plus K. And that is that. Part B, calculate the angle in degrees between the directions of MD and ON. Okay, when I check back here, MD, where is the M? M is here. MD and ON. So you can take this one like this, and like you can open up, you go like that. So MD, you dot it with this ON, and we have found these vectors. So MD, we are going to use, when we are finding the angle between two vectors, we use the scalar product. So MD dot it with ON, then this one will be equal to the modulus of MD, then times the modulus of ON, and then, or the magnitude, okay, then cosine of the angle that is in between them. MD is -2, -2, 3. Then ON, there is no I, but we have, what have you gotten here? 3J and then K. So 3J and then K, that means we shall have a 3 here and then a 1 here. Not so? If I can check, but this is -2, -2, 3. Okay, now we can proceed here. What do we have? We get their lengths, okay? So this one shall be equal to the square root of -2. Better you put it in brackets and you square, because when you square negative, you get a positive, right? Then plus this one here. Then the same thing that we are going to do here, 0 squared, then plus 3 squared, plus 1 squared. And then after that, we get the cosine of the angle in between them. So -2 times 0, that is a 0. Then -2 times a 3, that is a -6. Then 3 times 1, that is a 3, which is equal to, this is 4 plus 4, 8 plus 9. I think that is a 17. So we have root of 17. And then this is 9 plus 1, that will be 10. So root of 10, then the cosine of theta. So meaning that cosine of theta is going to be equal to -6 plus 3. What do you get? -3. Then you divide by root of 17 times root over 10. So meaning theta shall be equal to the arc cos of -3 out of, this is root of 17 times 10, using the rules of sides. You can just multiply those and then we have that. Now since this one is a negative, the answer is going to be, an obtuse angle that is in the second quadrant. So when these two intersect, we can get an acute angle here or the obtuse angle here. So what we get here, your calculator must be in degrees, okay? So shift, then mod, I'm converting this to degrees. Now shift, then cos, then we have a -3, we divide it by, there's a negative here. Then we divide it by the square root of 170. Then we get 103.3 degrees. That is to 1 decimal place. And that is that for this part. Then part C, show that the length of the perpendicular from M to ON is this one here. When I look at our diagram here from M to ON, this one comes like this, somewhere there. This one has to be 90. So we have to look for the equation of that line through O and M, okay? Then the point that we are getting here, okay, we are going to get this PM here. This vector is perpendicular to this vector here. So we dot them and then we equate to 0, okay? All right, now we are going to have, I've seen something like this. We have ON. Let me do a small sketch here. ON. It was like that. Then we have our M somewhere here. This is M. This is perpendicular. So this is O, and then this is N. Then a point that is a point that lies on a line, that means its coordinates must satisfy the equation of that line, okay? Now, of course, this M here, We got OM. Did we get OM? We can trace it back here. OM from O to M, that will be 4I, then plus AM. But right from here, we got our BA as OA minus OB. Now, when I'm finding AB, that one is going to be now BA minus OA. So it will be 4J minus 4I. Okay. All right. So let me do it here for you. OM is going to be equal to OA, then plus the AM. Now this is 4I, then plus, this is a half of AB. Then this is 4I plus a half. AB is OB, which is 4J, minus OA, which is 4I. Now, meaning you have 4I here, then plus 2J minus 2I. So my OM is going to be 4 minus 2, that is a 2. So it is 2I, then plus the 2J. That means here we have 2, 2, then 0, because there is no what? There is no, let me actually put this one here. It's just side work. We have something like that. So we're saying there is no K, so the Z coordinate is a 0 there. Now, what else do we have? We need to find the vector equation of this line here, okay, such that we can get the coordinates of P. Now, equation of line ON. This one I can say this is R, then plus the OO, because it is passing through the origin. Then I can just say O there, maybe O to O, whatever. Then plus lambda, then ON. So the directional vector is going to be this, ON. Now, of course, this one can be 0, 0, 0, then plus lambda. What is ON? Do we have ON? If we come back here, ON is here. So it is 0, 3, 1. That is good. 0, 3, 1. 0, 3, 1. So that means any point, in fact, this one can be written as lambda, then 0, 3, 1. So any point that is on this line has to satisfy this equation. So the x coordinate is going to be 0 times this lambda. Then the next one is going to be lambda times 3. So 3 lambda, and then lambda times 1. Now, we are going to dot. This PM here, you dot it with the directional vector of this one here. Or I can say MP, this vector here, dot it with the ON. Dot it with the ON. Then this one is equal to 0 because they are perpendicular vectors. So what is MP? You get OP minus OM. Okay? So we get this PM here. OMP, whatever. So this one is going to be, what are we going to have? We are going to have OP minus OM. So our OP is 0, 3 lambda, then lambda here, minus OM. Remember, we got it as 2, 2, 0. Then, what else are we going to have? So simplifying this one here will be the negative 2, then 3 lambda minus 2, and then lambda here. Now, I'll get this 2, then 3 lambda minus 2, and then lambda. Then we dot it with this ON here, which is 0, 3, 1. So we have 0, 3, 1, then we equate this one to 0. And then when we multiply here, we shall get 0, then plus, multiply here, what do you get? 9 lambda, then minus 6. And then here you get a lambda, which is equal to 0. So 9 plus 1, that one will give us 10 lambda, which is equal to, take the 6 this side, that is 6. Then lambda will be equal to 6 out of 10 by 2, you get a 3, by 2, you get a 5. After getting the value of lambda, they want the length of the perpendicular. So we need to get this MP here, then we get its length. So that means MP shall be equal to, remember it is here, so we have 2, then 3 times lambda is 3 over 5 minus 2, and then 3 over 5. So this one simplifies to what? Let me first separate this one here, extend this one a little bit just to create some space. Then this one will be equal to 2. Then 5 times negative 2, you get negative 10 plus 9. Negative 10 plus 9, that is a negative 1, then out of the 5. And then 3 out of the 5. So that means the modulus of this MP then is going to be the square root of 2 squared, then plus negative 1 over 5 squared, then plus 3 over 5 squared. Okay, now here we are getting the square root of, this one should give us 22 out of what? 5. Let's put this in the calculator and we see. 2 squared, then plus negative 1 out of 5. This one must be squared, then also plus 3 out of 5, then squared. We get 22 over 5, and that is that.